Okay, this is day 3 of the distance learning packet and math section. Okay, so again, we're focusing on functions for 8th grade math, and we are given this equation, y equals 2x plus 5, which is a linear function. We are told that, and we're asked to match or to which of these choices could be modeled by that equation. So basically, does this work for each of those scenarios? All right, so remember, 2, the number in front of x, is the slope or the rate of change. So the rate of change is 2. We don't know what, to what. That's dependent on the context of these different situations that we have here. And then the y-intercept, the b, is 5, or we also call that the initial value, and that's 5. Okay, so that'll help us to match up the correct descriptions. So think of it as a rule of 4. We have an equation, we want to know what the description is. Okay, so A, it says there are initially 5 rabbits, so that sounds good, right? Initial value of 5. Each month thereafter, the number of rabbits is 2 times the number in the month before. Okay, so that increases by 2 rabbits each month. So each month, or each, is a keyword for rate of change, and we are talking about 2 times the number. Okay, it's 2 times, 2x means 2 times that number. So situation A would match that equation. Okay, so I'm just going to circle it. Okay, the next one, Joaquin earns $2 for each magazine sale. Each time he sells a magazine, he also gets a $5 tip. How much money will he earn after selling X magazines? All right, so they give us those two values, right? Here's 5 and here's 2. Of course, to make us think about it, right? We can't just assume that just because there's a 5 and a 2 that it's going to work. So let's think about this. So let's think about every magazine that he sells. Okay, so this would be the rate of change. So he sells one magazine, how much does he get? So it's $2 plus each time. So every magazine, he also gets $5. So really he gets $7 per magazine. Okay, so $7 is the rate of change, which doesn't match our equation, which has a 2. Okay, so that does not work. So this would be y equals 7x, because he gets $7 every time he sells a magazine. Okay, part C. Sandy charges $2 an hour for pet sitting. Okay, an hour, right? An hour per hour, that's a rate of change, so that works. Owners are charged $5 if they arrive home later than scheduled, so if they're late. Okay, here we go. Assuming the owners are late, how much does she earn? So this is very important. If it just said, how much does she earn in X hours, then it depends if they're late or not. So that $5 is not always there. But if we are told that the owners arrive late, then this equation does work, because she has to charge that $5 for the fee and then $2 per hour. Okay. D, a sequence of integers. The first term of the sequence is 7. Okay, so let's figure out that first of all. So basically, if I'm making a little XY table, so if X is 1, so the first sequence, okay, so let's see if that even works. So if I put a 1 in there instead of X, so I have 2 times 1, that's 2. 2 plus 5 is 7. Okay. And if I put a 2, so that's the next term. If I put a 2 there, 2 times 2 is 4, plus 5 is 9. Okay, so there's our table. So it says the difference between any consecutive, so that means in a row, terms is always equal to 2. So if I think about 7 to 9, I'm adding 2. Okay, so that works. And he is saving money for a new game. He began saving with a $5 gift and will continue to save $2 each week. So there's our keyword each, right? Per week, each week. So there's our rate of change, so that works. He started, so initial value of 5. So that one works as well. So another way to do this without just reasoning through it is to choose some numbers and to graph it or make tables and see if it matches that equation. All right, so this one was pretty straightforward. We didn't really even need the graph. All right, so let's move on. So we have a rule of 4. This time we are given the equation. So remember last time we had C and P as well, and I said, I would choose C as cost and P maybe potato chips, Pringles, something starts with P, and you can create the rest on your own. So again, I will help you determine the slope. Maybe I'll start off with a table, and then I'll let you do the rest. So here's our equation. It follows the form. These are all linear, so that means they're straight lines. So this is how they always start off, okay? So instead of Y, we have C, that's fine, cost. M, okay, that has to be 3, so that's our slope. X is just the other variable, which is P in this case. And then plus B, so it's our y-intercept, so that is the 5. So slope is 3, and y-intercept is 5. So when we make our graph, remember, if we have a y-intercept, we're going to start off 1, 2, 3, 4, 5, right? We have a point on the y-axis. It's not going through 0. And then we go slope, remember, rise over run, up 3 over 1, up 3 over 1, right? Something like that. Okay, totally just did your graph for you. All right, a table. X and Y. Actually, even better, I would put what is X for this case, so P, and then Y is C. Again, you're going to have to do a description, so think about what you want those to be. I would do C as cost, and then P is something that would cost money. But think about this time, instead of just bags of chips, because if we buy no chips, we shouldn't pay any money. But this time we do have to pay something, $5, and then we pay for the items. So maybe ask your parents about the Blockbuster days where you had to have a membership, and then you would get movies at a discounted price or something like that. Okay, so creating a table. It doesn't matter where we start. I'm just going to start with 0 because think about our graph. First quadrant, so we have, this is our x-axis, so we have just 0 through some numbers. So I'm just going to go 0, 1, 2, 3. Okay? And I'm just going to replace this variable, P, with the number that I chose up here. So if I put a 0 there, 3 times 0, that's 0, plus 5 is 5. If I put a 1 there instead of P, 3 times 1 is 1, plus 5 is 8. If I put a 2 there, 3 times 2 is 6, plus 5 is 11. And just check mentally, we should be seeing that this goes up by 3 because that's our slope, that's our rate of change. So then this would be 14. Okay, again, I'm going to let you do the rest. Next. We have graph paper if we need it, and it says to graph this function. Okay, so plot the points, see what it looks like. It's most likely going to be a straight line. So here we have graph paper. Remember, it's not always just X over here and Y over here, all right? It depends on our numbers, so don't just assume that. Let's go back. So we need 0, 0, that's the origin. And then we need 1, comma. So I'm just going to do a little mental graph here. So 0, 0, 1, negative 2, 2, negative 4. Okay, so that's what we're going to need. We're going to need a graph that is like this. And it doesn't really have to be this big. So we have a point at 0, 0. 1, comma, negative 2. I'm going to skip some spaces just so we spread this thing out. So I'm going to say that every 4 blocks, let me just put some numbers in here. So 1, 2, 3, 4. So that's our 1. 1, 2, 3, 4. So that's 2. 1, 2, 3, 4. So that's 3. So let's space it out a little bit so it takes up a little bit more of our graph. And then the same going down the y-axis, I think. 1, 2, 3, 4. So that's a negative 1. 1, 2, 3, 4, negative 2. 1, 2, 3, 4, negative 3. So just make sure they're evenly spaced. We have 4 boxes between each number. Okay, so that's all we need. So let's go back and get our points. So 0, 0, and then 1 comma negative 2. 1 comma negative 2. 2 comma negative 4. 2 comma negative, so follow it down. There we go. Looking like a straight line. So I'm sure we could figure out what the next point would be, right? Okay, let me draw a line through there. Okay. Just make sure it all lines up. Yeah, perfect. So it's a straight line. Okay, so that's done. All right. Number 2, complete the table. So this is kind of what we did right here. So how do we make this table, right? We substituted numbers in for x. So we're going to do the exact same thing, and they give us the numbers for x. So we have negative 2, negative 1, 1, and positive 2. So I'm going to do this the long way. So 2, and then we substitute the x in, so that's negative 2 plus 5. So this is just like our function tables that we've done. So 2 times negative 2 is negative 4 plus 5 is positive 1. Okay, same thing here, except I put a negative 1 instead of x. 2 times negative 1 is negative 2 plus 5 is 3. And look at this. Here's our slope, right? We should see that our numbers increase by 2. All right, 2 times 1 plus 5, that would be 7. But look at that, it jumped by 4. Why is that? Because we didn't count by 1s on the x, right? We skipped 0. It should go negative 1 and then 0 and then 1. So if we did that, it would be plus 2 and then plus 2. So we just jumped over one of those points. Okay, and then from 1 to 2, that is 2, so that this will go, I'm sorry, from 1 to 2 is 1, so this will go by 2. So let's just make sure, 2 times 2, and then plus 5, so 4 plus 5 is 9. So yes, it does. All right, so we always check, like always think about this, make sure it makes sense. All right, number 3. This graph shows how many cookies Julia makes over 9 days. Okay, so here's 9 days, number of cookies, everything looks good. So the question is, how many cookies will Julia make in 7 days? So here's 7. Let me get a different color. So 7 days. So follow that up to the line. Okay, it touches there. And then we follow that over to the y-axis because that tells us how many number of cookies that she makes. And the number is 700. Okay. And I believe we just have our last part and then we're done. So again, I'll help you solve it. Leave the rest up to you. Okay, so I'm just going to rewrite it. So negative 4x plus 5 plus x plus 4 equals 36. So just a multiple step equation. Finding like terms. So here's an x term, here's another one, and then we have some constants or some numbers. So we're just going to combine those. So negative 4x and positive 1x gives us negative 3x, and a positive 5 and a positive 4 gives us a positive 9. That equals 36. All right, the x is on the left, so let's eliminate these other things around it. So let's start with the number. So we're going to subtract 9. So that becomes 0, which is what we want. So on the left, we have negative 3x equals, okay, now 36 minus 9, okay, that is 27, right? Then divide. We don't want negative 3x, we want just x, so we divide by negative 3 on both sides. And that is a 1 over here, which is what we want. So 1x, or just x, equals 27 divided by negative 3. Okay, so first of all, it's going to be a negative because the positive divided by negative is a negative. 27 divided by 3 is 9. So there's our answer. And of course, we should check it to see if it works. So if we go back to our original equation, I'm just going to do that right down here. So if I have a negative 9, so let's think in our head. Negative 4 times negative 9, just put negative 9 for each of those x's. So that's positive 36 plus 5 minus 9 plus 4. So let's think, 5 and 4, that's 9. 9 minus 9, that's 0. So all that's just out. So 36 equals 36, which is true. So our answer is correct. And that's the end of this one.